Hey guys, in today's video we're going to be working with the Ender 3v2. This particular one is running Kevin's Z-Belt mod along with some other upgrades that I've made over the years. In this particular video we're going to be talking about the Y-axis motor and how much heat that it generates. I've had a couple of people ask me if there's a way to reduce the heat created by the Y-stepper motor without having to adjust the V reference voltage. And I thought that was a good question. I realize that a lot of people don't have access to multimeters or are worried about opening up their printers and using metal tools inside on the motherboard. So I took the last couple of weeks to kind of analyze the problem and see if there was a way to reduce the heat generated by the Y stepper motor without having to adjust the V reference voltage. So guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. This particular Ender 3v2 still has the original V reference voltage, and it ranges from 1.10 volt to 1.2 volts on X, Y, and Z steppers. The extruder stepper is set to 1.43. So we're going to leave it the way it is. We're going to run a test print and we're going to measure the temperature of the Y stepper motor. We're going to be printing a Y tensioner arm. So let's slice it and see how long it's going to take. All right, so about 2 hours and 49 minutes. And after slicing files, I always like to look at them in preview mode to make sure that I got everything set correctly. And looks good on this side. All right, so what I notice here is that the seam is on the front. So this is the part that you're going to be looking directly at. I don't like that. So what I'm going to do is, well, actually I could probably just rotate the model because I got it set to put the seam on this side. So I'm just going to rotate this model around. And that will put that seam on the bottom. You slice it. And all right, that's much better. All right, so now the top face is going to be nice and clean looking. Upload it to Clipper and start the print. All right, guys, so let's check it out and see how we're doing here. So we're about 70% through the print. And so if you can see that Y stepper motor is really cooking. And the part that it's bolted to is the factory plastic housing. So that's the housing that holds the belt. You can see the end of the belt as it comes out, as it peeks out of that housing. It's real hot, so all that heat is being trapped in there and not being transferred away from that motor. So if you notice the rest of the stepper, so this stepper right here that that is right behind that little plus sign, so that is the extruder stepper motor. And since this machine has the Kevin Z-Belt mod, it's bolted to a piece of plastic. So again, this one is also cooking pretty good. It's got no way for it to transfer its heat anywhere because of this this plastic part that it's bolted to. So if you look at the one in front of it, so this is the X-axis stepper motor. It's pretty cool. I mean, it's not cold, but it's nowhere near as hot as the other ones. And the reason that this one is much cooler is because it's transferring its heat to the aluminum bracket. You can see the aluminum bracket kind of in green there. And then it's a little bit green and kind of yellow in the middle. So that's where the heat is going. It's also transferring it over to this aluminum extrusion. You can see it. So the right side of the extrusion is much cooler, and as we get closer to the stepper motor, the temperature on the aluminum extrusion and the bracket rise. So if you look at the bottom here, the bottom extrusion is currently 97 degrees, and as we come over to the back, you can see again 98 degrees towards the y-axis stepper motor, but because of that plastic part that is bolted to, it can't move any of that heat away from it. Give this thing kind of like a hand test and see how hot this thing is. Wow. Yeah. Yeah, things. Yeah, especially right here. Yeah, this thing is super hot. Check the other stepper motors. So this is the X stepper motor, and this one I can put my hand on. It's pretty warm, but it's not gonna burn my hand. I can keep it on here. Yeah, but the other one will roast me. Let me check the extruder stepper. Extruder steppers. Yeah, that one's hot too. All right. So one thing never to do is don't touch the printer while it's printing. So as this thing was printing, I was touching uh, the gantry, and it caused this layer shift here. So lesson learned. All right, so I have to reprint this part. So what I'm going to do is remove the stepper motor, shut down the printer, and to take it off, it's got an Allen key, Allen screw right here. You just got to unscrew this, and to get this little cover off, you have to kind of grab it and then rock it to get it off, and it just pops off like that. Unplug the limit switch, and then underneath here there's a couple of Allen screws. Yeah, if I tilt it up, you can see those two right there. So I'm just loosening the belt. Unplug the Y stepper. Get the belt off. Just grab it with some tweezers or something, and just pull it out of there. And so this is the. So here's the plastic housing. So what I think we need to do is recreate this, but instead of it being made out of this material, this plastic, this thing needs to be made out of aluminum. That way, since the motor is bolted to the aluminum will act like a heat sink, but it will also transfer that heat to the to this big 40 by 40 millimeter extrusion, and that should cool this thing way down. All right, so let's unmount this thing, and I have to redesign this in CAD, and then have it CNC'd out of aluminum. All right, guys. So here's where we're at. I took the screws out of the housing. So now we got the stepper motor off, and I'm super excited. The prototype parts came in. So let's open them up and check them out. Looks awesome. And there's also a cover if you guys want to go the extra step and relocate the limit switch to a 3D printed part that will allow adjustment. But what we can do is we can reuse this one. So if you want to, so there's two ways to install this. You can install it this way using the original end stop cover. But to get it to work, we're gonna have to cut these little feet off. So I'm just gonna snip those off. And snip off the last one. All right, let's test fit it. So it gets mounted like this, and then this part goes here. And screw should line up inside. Let's see if it lines up in there. Yep. There's the hole. All right, perfect. So let's go ahead and install this, and then we'll run another test print and see how it does. So now the original screws were shorter than these. So the original screws are, looks like they're 6 millimeters. We're going to need the next size up. So these are 8 millimeters. And the way that you bolt it down is, so if you're looking at it from the side, you would see it like this. And the stepper motor plug needs to go face down. So it bolts up just like this. So plug face down, or plug along the same area as the two screws on the bottom. And honestly, I'm surprised the manufacturers haven't figured this out yet. You would think that having the stepper motor baking like that and them not coming up with a solution other than to put a warning label on the stepper motor saying, hey, be careful, this thing is hot. All they would have had to have done is just create this part and upgrade the printer. I realize these guys are always trying to hit a price point. I mean, I get that. And CNC machining isn't cheap, but if it's going to increase the longevity of the tool, then in my opinion, I can't see why somebody wouldn't want to spend a little bit more and make sure that their investment lasts a long time. All right, let's bolt it to the printer. I'm going to start by putting the belt on and then plugging the stepper motor back in. And lastly, the limit switch plug. And this one's kind of tricky to get in. I find that using a set of tweezers or an Allen key or something to kind of guide it in there is easiest. And once it's on there, all you got to do then is just put it on and then put the screw down. So it also comes with a cover, so you can use the cover with the screw and then relocate the limit switch, take it off of this original plastic housing and mount it onto a 3D printed part. So it would be like this, and then this would be on the rail, so you can move it forward and back to get your adjustment just right. I find that the current position of the switch is a little bit, it's about 5 millimeters too far to this side. So it actually takes away a little bit of your y-axis build surface. So by printing this part, you get that 5 millimeters back. But anyway, it's going to be. I'll include these in the final version, so it'll be the housing, the cover, and the longer screws. And then if you guys decide that you want to use the adjustable part, then you can just download that from the link in the video description, 3D print it, and then just bolt it on there and then use this cover instead of the original. All right, to get the belt tension, the proper amount, what we're going to use is this little tool here. So this is a little reproduction of the Prusa gauge. And I like to tighten it up to about the second level here. So about right there. So I'm just going to go ahead and install it. And the way it installs is the belt goes over the outside feet, under the middle one, and then back over the pin on the other side. Once you get it on, all you got to do is just start tightening it up until that gauge gets to the second little line, and that's it right there. It's kind of hard to see. Let me see if I can get some light on it. There you go. So you see the little arm right here. So it's currently on the second notch from the low position. And just pull the tool out, and now your tension's good. And you want both the Y and the X tension to be the same. All right, so let's get this thing printing, and then we'll check the thermal image again. All right, let's check the stepper motor, the Y stepper. And there you can see that now it's transferring heat to the aluminum housing. And if you notice, the belt is not red anymore. So it's significantly cooled off. It's also transferring heat to that aluminum extrusion. So yeah, big difference. Here are both of them back to back. So the first one is stock V reference voltage and stock housing. And now we have the aluminum housing with the stock V reference voltage. Big difference. Right now the X is set to 1.2. It needs to be 0.91. Hopefully my hand won't get in the way. Just turning it down. There's 0.91. So right now is also 1.2. That's good. Next. This one is also 1.2. Good. And then the extruder is going to be 1.1. So right now it's 1.4. And I'm just nudging it just a little bit. It's good right there. Done. Let's close it up and we'll try another test print. This is where we are so far. And you can see, yeah, a lot cooler. A lot cooler. And it's not just the Y stepper motor, but also the Z axis motor. It's, 103 degrees. 101. This one is still over 105. It's just over 105. It'll say high. So it doesn't look like it's over 105 by much. So I got a 104 there. And then this one is still pretty warm. This is the extruder, and that's because it's not mounted to anything aluminum. And then you got the X stepper motor, super cool. So that one is what did it say? So yeah, again, just anything over 105 is going to say high. So I mean, it's like on a borderline. All right, so I think this is a good, successful test. This thing is just warm now. Yeah, big difference. All right, guys, if you're new to the channel, consider subscribing. Turn on your notification bell and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. All right, guys, this video is a wrap. We'll catch you in the next one. Take care.